So in section 4, what I might end up doing is sharing the answer key to this, because he's going to explain this in a little bit more detail. But basically, we are looking at multiple functions, f and g, and let's say we already knew that the limit as x approaches a of f of x equals L, and the limit as x approaches a of g of x equals M. Can we just simply say that when we add the two functions together, as long as everything is satisfied is what they have, we can just split them up into two separate limits? So maybe I'll do the first one, the limit as x approaches a of f of x plus the limit as x approaches a of g of x. So what we're boiling it down to is that this piece equals L, this piece is equal to M. So what I'm trying to get at is that we can find each individual limit and then add them together. And just so you're clear, L and M are just numerical values. So the same thing will happen with a difference, a subtraction, that you can just say, okay, we'll find the first limit, which is L, the second limit, which is M, and subtract them from each other. And the answer key just puts this middle step in here for you. So the same thing goes with the next one, as you do each individual limit, and so we can divide. Now this one, you might want to put in a little disclaimer here that you can never divide by 0, so M cannot equal 0. But for the most part, that does not happen. The next one, same thing. You can just split them up into two separate limits, so you can multiply them. Just find each individual limit and then multiply those values together. Same thing goes with the next one. Maybe I'll show you the steps on this one, although it's probably actually more beneficial to explain number 7, because if we've understood our direct substitution in this problem so far, you'd plug in a in for the x value here. Well, there's no x value to plug in, so the limit as x approaches a of any constant is just going to be the constant value, which might actually explain number 5 a little bit better, that it's going to be c times L, just like that. And same thing with this one, where all you have to do is find the first limit and then take it to the p power. And these are going to be useful for you as we move forward. So here's an example on how we can apply these formulas. We have the graph of f of x, we have the graph of g of x, and you just have to find each individual limit the way it is stated. I'm tired of writing in that color, so let's switch it. So x approaches 2 from the left side. Well, 2 on the left side of f of x is this value, so that's equal to 3. And 2 on the left side of g of x is 1, and then you can just add those values together, so the answer will be 4. Certainly easier than creating the new graph of f of x and g of x combined together. You can just believe me on that this will save you some time. So in the next problem, you're finding each individual limit. Now it's just the limit as x approaches -1, so you need to make sure it's the same value on both sides. And I need to count, because it's tough for me to read that. It should be 2 times -6. And -1 on the left side, that looks like -1. And as you multiply, -12 turns into +3. That answer looks like -9 to me. And same thing with the next one. X approaches -3 for, on the left side of -3 on the right side. Even though it's undefined, it does equal a value, -2. And then -3 on this one is not a numerical value. So basically, like a -2 minus a does not exist. Well, here's an example. Well, how do you do a problem where it doesn't, a -2 minus it does not exist? Well, we cannot in this problem. There will be times when you actually can in a certain instance. And maybe I should find an example like that, but not with that example. So just off the top of my head, with an example that maybe maybe you wouldn't even think about is, let's call this f of x, and let's call this, I don't know, g of x. And I don't know, let's look at the limit as x approaches 3, because I just want a random value of f of x times g of x. And maybe I make f of x be the function defined like this, and this function. And maybe I'll just make, what do I want to, maybe I'll make it the same exact value. Same exact function for f and g. Because what some students will say is, oh, well, the limit does not exist for f. So this would be the wrong way to do this problem. Does not exist for f, which I would agree, -1 on the left, +1 on the right. And for g, does not exist. Same reason. But if you were to do each individual problem and you just did the left side, so the limit, I'm trying to change colors for you and failed miserably. Yeah. If I asked you to do the limit as x approaches 3 on the left side, by the way, you will notice I do handwriting sometimes like this. Now you can do the problem, right? Well, on the left side, it's -1, and on the left side is -1. Well, what's -1 times -1? It's +1. Well, now let's do the limit. Since I did not do cursive here, I'll go ahead and do this. Of 3 from the right side of f of x times g of x. Okay, well, now it's +1 times +1, so it is +1. And remember, our definition of the limit is if the left side equals the right side, then the limit does exist. So this limit does exist. I'll go back to purple, because the limit on the left side is equal to the limit on the right side, and that value is 1. So be careful. Not all problems that involve does not exist will end up being a does not exist, but our rules do apply for everything else. I wanted to make sure I touched base on that since I warned you about it. You might have to do a two-sided limit. But in this problem that we already worked through, this is a no solution. That does not work. So as we look at the limit as x approaches 6, I'm looking at 6 because it's a continuous function right here. It's pretty clear that f of x is -4. So what we have here is -2 times -4, and g of x as x approaches 6. 1, 2, 3, 4, 5, 6. Looks like it's up to 6. And as I'm looking at that, just make sure you do a negative times a negative is positive, and then reduce that fraction is ideal, 4/3. Limit as x approaches 4 for each of these functions. So 4 looks like -3 for f. Looks like +4 for g. So 2, I think I said -3 times 4. And you get -24 there. So as x approaches -2 for the f function, so -2, 1, 2, just count down, looks like -5. And all of our rules for math do apply, like, find the limit first, then square it. Well, when you square a negative, you get +25. And then same thing with the next one. Limit as x approaches 2 on the right side of the square root of 2 times g of x. We'll find the right side of x equals 2. Now the right side is this function up here. And as I count that correctly, 1, 2, 3, 4, 5, 6. Please let me know if I'm doing bad math. which that would be the square root of 12, and it would be nice to practice finding the square root of that and simplest radical form. I hope you're familiar, like 4 and 3, 2 and 2, and put your pairs in front, 2 root 3, or however your previous teachers have taught you. It's totally fine with me. 2 from the right side again, well, we just found the right side of g of x was 6. That's from this previous problem. The right side of f of x looks like it's negative 2. Please double check my work. So I would rewrite that as negative 1/3. And then negative 1 for f of x. So I'm looking at negative 1 for f of x is definitely negative 6. I feel like I already did that problem. And the left side, let's see, negative 1 for g, looks like that's negative 1. And just make sure you're good at subtracting or adding. So just to put in a few more problems with you with this is being able to plug in. So as we look at this next problem, just a reminder is we want to make sure we write limit until we start plugging something in. So right now I'm just going to replace g of x with what it's equal to. Notice how I'm putting the parentheses in there. That does matter. And then plus g of negative 2, we'll just plug in negative 2 in for x and figure out what that is. So that would give me negative 6 plus 2 is negative 4 all over x. Now you would want to simplify this because I can distribute that in. That would be 6x plus 4 minus 4. Notice I still have an x in the problem, so I have to rewrite the limit as x approaches 0 all over x. And as you notice, at least I hope you notice, that these 4's will cancel, and then you have 6x over x, which those would cancel. Oh, kind of missed that. So our answer is just 6. And then this last problem is probably something you saw in pre-calculus, where you were asked to do quite a bit of work, where when I teach it, at least, I usually tell students to leave h alone on bottom. Leave f of x alone on top. Notice that I am putting in parentheses because you do need to make sure that you distribute that negative to all of those. And then f of x plus h means taking out all of these x's and replacing them with x plus h. So now when I take my next step, I'm just going to FOIL things out and distribute 2 in there. So try this on your own. Feel free to pause the video. Make sure that you're getting the same thing as I am. It looks like I'm going to run out of space. I'm going to start putting things kind of in a weird place, but you'll probably see why I put them where I did. Because you end up with a minus 3x plus 3x, a plus 4, a minus 4, a plus 2x squared, minus 2x squared. And of the remaining terms that did not cancel, you have an h that is shared in there. So we have the limit as h approaches 0. I can factor out an h in all of these problems. The ones that are left over, all over h. I put it there for a reason, so you can see that these cancel. And now I can use direct substitution, put 0 in for this h, and 0 times anything is 0, and all I'm left with is 4x minus 3. So our final answer has an x in it, which is okay. We can figure this out in a little bit. End of this video. Please come back for the next.